So April of 2020 is how many months after September of 2019? Okay, if we start at September, this is literally what I do as I do this as a math teacher. I literally am like, okay, September of 2019, September to October, November, December, January, February, March, April. That's 7 months. Since that time. So September to October is the first month. October, November, December, January, February, March, April. Okay, that's 7. So t equals 7. So then all I have to do is plug in 7. Z of 7 is equal. And we know how to calculate that. So let's just go ahead and jump into it. That's 385.39. So it says number of, right? Which we know means we can't have decimals. And so that's going to be 385 students. Boom. How long will it take for the population of zombies to double? So, how long? I'm solving for T. Sorry. Zombies to double means my initial value was 240. Double of 240 is going to be 480. So, okay, 480 is going to be what's equal to this guy. And then we can numerical solve. If we numerical solve this guy, we get that T is approximately 10.2 months. If we pause and assess, does that make sense? 7 months, we were at 385. So 3 months later to be at 480. Yeah, that makes sense. It's not too far out of the realm of understanding, and it's above what we got before. A school counselor estimates that ASM can sustain at most 1,000 IB zombies. In what month and year will the population reach 1,000 zombies? So break down what you have. We want to solve for time. We want to be specific about the time. So we'll know that that is a warning to future us that we have to answer the problem appropriately. And we know that the zombies will be equal to 1,000. Go ahead and solve for T, not necessarily solve for the problem. So I just want you to solve for T, and then we can talk about how we turn this into month and year. So we set this guy equal to 1,000. We numerical solve, and we get that T is approximately 21.0929. So, okay, 21 months later. I'm literally going to sit here and count to okay, that's just shy of 2 years. First of all, it's 3 months shy of 2 years, right? 2 years would be 24 months. So you could try to work smarter, not harder. But if you are at the bare minimum, I could just count the months using my fingers, right? So September to October, November, December, January, February, March, April, May, June, July, August, September, October, November, December. Keeping track of my years. January, February, March, April, May, June. Okay. I just counted to 21 on my fingers. As I was counting through, I then kept track of the years and was like, oh, okay, that's in June of 2021. If you realize that that was 3 months shy of 2 years, right? So then September, August, July, right, would be, and then June would be 3 months back, 2 years later. So just be careful about the wording here, right? If you got 21 months later, you wouldn't get full marks. this would be like an accuracy for this answer and then another accuracy for answering it the way they want you to answer it. Okay, last question. Population growth is often exponential. So anytime you see something about population growth, they're talking about exponential. They've given you a partial exponential or a partial exponential equation. This is not population growth. This is population decay, but the same thing happens. How I know that it's decay is that this number is less than 1, right? If that base is less than 1, then it's going to slowly decrease, a 5% decrease, right? 100% minus 5%, 95%. Okay, population of bees in a hive after T weeks is given by this. We have more variables than we are supposed to have in an equation. We should only have one input, one output. Output is this guy, which is telling us that our input is T. So pausing to say like, hey, this is just a number. Hey, this is just a number. That is an important first initial thought to have when you're looking at these equations of like what is supposed to be a variable and what is supposed to be a number. Okay, A and B are supposed to be a number. And notice they want you to find for values A and B. Then they've given us, initially there are 2,500 bees, and after 2 weeks there are 2,383 bees. Okay. Well, we have two unknowns, and they've given us 2 points. This is starting to feel like a system of equations. And let's see what happens when we plug these values in. Are they linear equations that we get as we go through? So initial means T equals 0 and P equals 2,500. So if I were to create that equation, I would get 2,500 equals A times 0.95 to the 0 power plus B. So this is a linear equation. The reason why it's a linear equation, yes, anything to the 0 power goes to 1. But even if you had a number up here that was an exponent, it's a number being raised to an exponent. It's not a variable being raised to an exponent. So as long as none of your variables are being raised to an exponent, then you can use the linear systems of equations, linear equations in your calculator. If I wanted to simplify this out and do A plus B, because this is just 1, anything raised to the 0 power is just 1, and then A times 1 is just A, I could do that, or I could type out this entire equation raised to the 0 power. And I'll do that later and I'll show you. Okay, but I have another point as well because I've got 2 unknowns. I need 2 points. 2 weeks, there's 2,383. And so I'm going to plug both of those into my systems of equations. And I'll show you. I'll do A times remember to do the times symbol with your systems of equations. As opposed to just parentheses, right? We don't want to, parentheses doesn't automatically register as multiplication. Definitely practice typing this into the calculator to make sure that you're typing it in correctly, right? This is where we learn about how we should be typing it into the calculator, and we learn by doing, not by watching. So definitely follow along, type this in, make sure that you typed it in the same way that I did, with the times in between the parentheses and the variable. When you press enter, you should get those values where A is 1,200 and B is 1,300. Then it says to find the population after this amount of time. So we've created a model, right? If we go back to this, that means that P of T equals A, which is now 1,200 times 0.95 raised to the T power plus B, which is 1,300. So now we've created our model. Now we evaluate our model. We interpret our model, right? The classic steps. We create it and then we interpret it. Population after 3 weeks and population after 5 weeks, you should be able to do this on your own. So I'm going to let you go ahead and do this. You could use just plugging in these values by plugging it in here on the calculate section of your calculator, or you could go to the graph section of your calculator and graph trace if you want. But go ahead and find these on your own. So P of 3 should be about 2,328. And if I pause and assess, that makes sense because after 2 weeks, it's 2,383. So it goes down just by a little on the 3rd week. P of 5 is then approximately 2,229 bees, which also makes sense. 2 weeks later, it's still going down just slowly at a time. All right. State. State means it should be easy, right? It should be on the page. It's kind of like write down, okay? So state the horizontal asymptote and interpret its value. So our horizontal asymptote is always going to be the C piece, right? So that is in the equation. You've already solved for it. So state the horizontal asymptote. Technically, horizontal asymptote is an equation of a line. So you should write it as an equation of a line. Y equals 1,300. This class, they probably won't mark you off if you don't do that. However, if they word it as like state the equation of the horizontal asymptote, then they would mark you off for not doing y equals, because equations have to have equals signs, right? An equation has an equals sign. So just be careful. They might be picky about that, or they might not be picky about that. It's all dependent on the wording. So if you wrote 1,300, it would be correct. But it's better if you did y equals 1,300. And what does this mean? It means if we're talking about population decay, it means that this exponential model, and it says interpret, so in context. So instead of saying exponential model, I'm going to say that the population of the bees is approaching 1,300. And maybe I'll say infinitely. Approaching 1,300, but will never go below. And that is the piece that really is like the contextual piece. Like the population of the bee just won't ever go below 1,300. And that's it. Okay. That's it for now. Good job, and I'll see you later.